Hi, this is Krista Garakis, and we're going to talk about scientific notation. Um, Scientific notation is different from chemistry because we use significant figures. It's basically so we can show large and small numbers using powers of 10. So, if we had 105, for instance, we would pretend that there's a decimal here, and then we would move it over. So it would become 1.05 times 10 to the second. So in this case, what's significant is a 105. So we would 1, 2, you want to make sure you move it so that there is only one number in front of the decimal. So it becomes 1.05 times 10 to the negative 2. So here we're going to move the decimal. So it becomes 6.4 times 10 to the negative 6. So it's a negative if it's less than 1. It's a positive exponent if it's greater than 1. So here we pretend our decimals here. We go 1, 2, 3, 4, 5, 6, 7, 8. And it becomes 6.4 times 10 to the 8. So the deal is scientific notation rules, we only want to use significant digits in scientific notation. So for example, if I had 100.00, all of that is significant. So I would move the decimal 1, 2, so it would become 1.0000 times 10 to the second. You want only one digit in front of the decimal, meaning that you always want 1 point something like this times 10 to the third. So it would be wrong to put like 0.3 times 10 to the third. That would be wrong. Power of 10 depends on two things, on number of places decimals moved and direction decimals moved. So in number 4, if our number is greater than 1, we move our decimal to the left and power of 10 is positive. So let's say I have 56,000. So we're going to pretend our decimal is here, 1, 2, 3, 4, and it becomes 5.6 times 10 to the fourth. So if number is less than 1, we're going to be moving to the right and power of 10 is negative. So for example, if I have 0.00050, I'm going to move it 1, 2, 3, 4. It becomes 5.0 times 10 to the negative 4. So some examples. What's significant here is the 238. Okay, so we pretend our decimal is here. It's 1, 2, 3, 4, 5. So it becomes 2.38 times 10 to the fifth. Here, only the 4-3 is significant. So we're going to do 1, 2, 3, 4. It becomes 4.3 times 10 to the negative 4. Here, the 289 is significant. Remove it 1, 2, 3. It's less than 1, so our exponent is going to be negative 2.89 times 10 to the negative 3. And here, we have a number greater than 1. So we pretend our decimals here. It's 1, 2, 3. It's 7.4 times 10 to the third. All right, so example 5 is not proper scientific notation, so we need to get it there. So we're going to pretend our decimal is here. So we're going to do 1, 2, 3. So only the 5 is significant. So it's 5 times 10 to the third. We still have the 10 to the fifth. So it becomes 5 times 10 to the 8th. Here, only the 5 is significant. Pretend our decimals here. It's 1, 2, 3. So we only put 5, okay, not 5.0. That means if it's 5.0, that means that we have 2 significant figures. We only have 1. So that's why we put it that way. Here, this is not proper scientific notation. So 1, 2, 3. So we do 8.9 times 10 to the negative 3. We still have the times 10 to the negative 3. So we're going to end up with 8.9 times 10 to the negative 6. Here, everything's significant. So we move our decimal 1, 2, so it becomes 1.0000 times 10 to